Welcome to AI Patent Watch, the podcast where we break down an exciting AI patent in each episode, what it covers, why it matters, and how it's impacting innovation. Whether you're a patent professional, an AI enthusiast, or an inventor looking for inspiration, you're in the right place. Let's dive into today's AI patent.
You know that feeling, right? When you're talking to your voice assistant and it just cuts you off.
Oh, definitely. Before you've even finished your thought.
Exactly. You're maybe halfway through saying something, trying to remember a name or find the right word, and bam, it's already trying to, call someone or play the wrong song.
Yeah, it's like someone finishing your sentences, but getting it wrong half the time.
Whereas, when we talk to each other, there's a natural flow. We pause.
Yeah.
We might say, we gather our thoughts.
Right. And those pauses, they mean something. They're not just dead air. They signal you're still thinking or maybe you're refining what you want to say. Older assistants just, wow, they didn't really get that.
Okay, so let's dive into this because we found something really interesting, a European patent that actually tackles this exact problem.
Ah, yeah.
Yeah, it was granted just last year, April 23rd, 2025. It's EP4 158-621B1. And it's all about making these voice interactions feel less robotic, less turn by turn, and, more human.
Okay, that sounds promising. So moving away from that stilted back and forth.
Exactly. This patent, it was filed by Google LLC back in, November 2021. The inventors listed are Jacqueline Konzelman, Trevor Stroman, Jonathan Bloom, Johan Schokwick, and Joseph Smart.
A strong team. And Venner Shipley LLP handle the patents side of things. So Google's trying to make their assistant understand conversational pauses better.
That seems to be the core idea. And for you listening, this is a really cool chance to peek behind the curtain at the cutting edge of voice AI. We're going to explore why those older systems felt so, clunky sometimes.
And then how this patent proposes to fix it, right? Like the aha moment behind the tech.
Exactly. Understanding those limitations and then seeing the clever solutions.
So our mission for this deep dive is basically, what was the state of the art before this patent? What were the big frustrations? And then how does this invention actually work? What's the mechanism?
Spot on. And, thinking about this kind of complex tech, it really highlights something important.
What's that?
Well, protecting these kinds of intricate ideas, like combining speech tech with understanding conversational flow, it's not simple.
No, absolutely not. Especially in AI and software, getting the patent right, making sure it actually covers the core innovation, that takes real expertise.
Right. It underscores the value of having, experienced patent attorneys who don't just know the law, but deeply understand the technology itself.
Absolutely. Someone who gets the nuances, like yourself, Bastian Best, our host, who specializes in AI and software patents here in Europe. Having that deep tech knowledge alongside the legal expertise is, I'd say, crucial.
Well, it certainly helps to understand what you're trying to protect. But okay, let's rewind.
Yeah.
Before this patent, what did the typical voice assistant setup look like? How did it go from me speaking to getting an answer?
Okay, so the traditional pipeline, you could call it, had a few key stages. First, your voice goes into automatic speech recognition, ASR.
Right, turning my speech into text.
Exactly. Or, more accurately, into text hypotheses, the system's best guess at the words. Then that text goes to natural language understanding, NLU.
Okay, figuring out what I mean. My intent, like play music or set timer.
Precisely. Identifying the intent and any specific details, the slots like the song title or the timer duration. And finally, there's a fulfillment engine.
Which actually does the thing, plays the song, sets the timer, gives the answer.
Correct. ASR to NLU to fulfillment, like a relay race, as you said earlier.
Okay.
But the key limitation, the thing this patent addresses, is that most older systems worked on a very strict turn-based model.
Meaning
You speak, then you stop. The system detects that stop, that silence, and then it really kicks off the main processing NLU, fulfillment. Then it generates its response. It waits for your turn to be definitively over.
Ah, okay. I can see the problem immediately. Real conversations don't work like that, do they?
Yeah.
We interrupt, we pause mid-thought.
Exactly. That turn-based model feels unnatural. Like the patent points out, humans often convey one idea over several little bursts of speech, maybe with pauses, we can follow that. But the old systems, they'd often treat the first pause as the end.
Right. Like if I said, can you call Sarah, and pause to remember her last name.
Perfect example. The old system might hear, call Sarah, see the pause, assume you're done, and then either ask which Sarah, or worse, just dial the first Sarah in your contacts.
Even though I was clearly just thinking for a second.
Right. It didn't understand the nuance of the pause. It just registered silence and assumed end of turn. Those natural pauses, disfluencies like they just tripped up the older system.
Leading to frustration, having to repeat yourself.
Yeah.
Yeah, not a great experience.
Not at all. It felt inefficient and frankly kind of dumb sometimes.
Okay, so this brings us to the patent. How does it get around this turn-based limitation? What's the core idea?
The core idea is pretty elegant, actually. It's about enabling the assistant to make a much smarter guess about whether you've really finished speaking or just paused.
And how does it do that?
It does it by looking at two things simultaneously. Not just what you said, that's the NLU part, but also how you said it. It analyzes certain audio-based characteristics of your speech.
How I said it, like my tone of voice or something.
Exactly. Things like tone, intonation, rhythm, stress, even if you stretch out a word. It combines the language understanding with this analysis of the actual sound patterns.
Interesting. So it's listening on multiple levels.
Precisely. And it's doing this in real time using something called streaming ASR and streaming NLU models.
Streaming, meaning it's processing as I speak, not waiting for me to stop.
You got it. Think of it like a live interpreter who starts translating while you're still talking, not waiting for the whole speech. So there's a constant flow of text hypotheses from the ASR and potential meanings from the NLU.
Okay, that's already a big shift from the old wait till silence approach.
Huge. But then crucially, at the same time, it's analyzing that raw audio stream for these audio-based characteristics.
Right. You mentioned tone, intonation. What else specifically does the patent talk about? What kind of clues is it looking for?
It gives quite a few examples. Intonation, like whether your voice goes up or down, tone of voice, stress on particular words, the rhythm and tempo, are you speaking quickly or slowly, pitch.
Okay.
And really specific things like elongated syllables. Like if you say call on Knowles, stretching out that vowel, that's a big clue.
Yeah, it usually means you're hesitating or thinking.
Exactly. It also looks at pauses themselves, of course, and maybe even the grammar around a pause. All these things together can signal if you're still formulating your thought, maybe your emotional state, or even if it's a question versus a statement.
And how does it detect these? Is it like specific software components?
Yeah, the patent mentions something called an acoustic engine. This engine might use machine learning models trained to spot these characteristics, or maybe just a set of rules. Its job is to constantly analyze the audio signal for these subtle cues.
Okay, so it's got the words coming in via streaming ASR and LU, and it's got these audio clues from the acoustic engine. How does it put them together to decide? Pause or full stop?
That's the job of another component, which the patent calls the pause engine. This engine takes the audio characteristics, and it can also look at the NLU output stream, and it essentially makes a prediction.
A prediction about whether I'm done.
Yeah. It tries to perform what they call soft endpointing. It's deciding if the utterance feels complete based on all the evidence, even if there wasn't a long, hard silence. Again, this might use machine learning like an audio-based classification model.
Soft endpointing. I like that term. It captures the nuance. So what happens if this pause engine decides, okay, they've paused, but they're probably not finished?
Right. This is the clever bit for making it feel natural. If the system detects a likely pause, and it sees from the NLU output that it could technically fulfill the request so far.
Like in the call Sarah example, it knows the intent is call, and the contact might be Sarah.
Exactly. Even though it could act, the invention says, don't. Refrain from fulfilling the request immediately. Hold back.
Okay, it waits. But doesn't that just create an awkward silence?
Ah, no. That's the other part. To avoid that dead air, it generates what the patent calls natural conversation output.
Like what? What does that sound like?
Think of those little sounds we make to show we're listening. The patent gives examples like mm-hmm or
uh-huh. Oh, okay, like verbal nods.
Exactly, just little acknowledgments. There's a specific natural conversation output engine that picks these. And interestingly, the patent suggests these little sounds might even be played at a lower volume than the assistant's normal voice.
Subtle. So it feels like it's just tracking along, not interrupting.
Precisely. And if the device has a screen, it might show the words you've said so far, maybe with those little bouncing dots to show it's still listening, or an LED might pulse or something.
Right, visual cues too.
Yeah. And crucially, while it's doing this, playing the or showing the dots, the streaming ASR and NLU are still running, still listening, ready for you to continue.
Okay, this is making a lot more sense. Let's use that Call Arnold's example again. Walk me through it with these components in mind.
Sure. So you start saying, call Arnold's. The streaming ASR picks up the words, maybe hypothesizing, call Arnold's. The streaming NLU identifies a call intent, potentially with Arnold's as the entity.
But the acoustic engine hears that stretched wall sound.
Right. It flags that elongated syllable as a strong indicator of, well, hesitation or incompletion. The pause engine takes that audio cue, maybe sees the NLU output is plausible but not fully specific yet, and decides, user has paused, likely not finished.
So no premature dialing of Arnold.
Correct. Instead, the natural conversation output engine generates a quiet,
giving me the space to finish.
Exactly. Then you continue, Trattoria. The streaming AS-RNLU instantly update with the full name. Now, the pause engine, maybe after a short natural pause following Trattoria, determines you have completed the thought.
And then it initiates the call to Arnold's Trattoria.
Spot on. Contrast that with the old way, potentially calling the wrong Arnold, forcing you to cancel and start over. Much smoother, much less error-prone.
Yeah, that's a world of difference in user experience.
Yeah.
What about the other one? What's on my calendar for? Similar logic.
Very similar. You say, what's on my calendar for? Again, that elongated her. The NLU gets the calendar lookup intent, but it sees the date slot is empty.
And the acoustic engine flags the stretched sound.
Right. So the pause engine says, hold on, intent clear, but key info missing. And the audio suggests there's still thinking. So it refrains from guessing a date, like maybe today.
And maybe gives another.
Exactly. It waits patiently for you to provide the date, like tomorrow morning. Then, once you provide it and pause naturally, it fulfills the completed request.
It's context aware, using both language and sound. Very cool. So what happens when it does decide I'm finished? Is it just based on silence after the audio cues stop?
It's likely a combination. Once the audio cues suggest completion, like normal intonation at the end of a phrase, no elongated sounds, and maybe there's a brief natural pause, the pause engine signals, okay, looks like they're done. Then the fulfillment engine takes over and generates the response or performs the action.
Makes sense. The patent also mentioned time, like the duration of pauses. How does that fit in?
Yeah, there's a temporal engine mention. It adds another layer. The system might wait a certain short threshold, maybe n seconds, after detecting a pause before it even gets the
Okay.
And if you stay silent for longer, say, beyond a further threshold, maybe m seconds, it might escalate. Instead of just it might prompt you more directly, like you were saying, or anything else.
So it adapts based on how long the silence lasts?
Yeah.
Tries to be helpful without jumping in too soon?
Exactly. Trying to find that balance between waiting patiently and preventing the conversation from just stalling awkwardly.
And there was one more thing. Computational costs.
Yeah.
How does that influence whether it waits or acts?
Right. This is quite sophisticated. The system can weigh the cost of acting on potentially incomplete information versus the cost of waiting or having to undo an action.
Can you give an example?
Sure. Take the calendar example again. What's on my calendar? If you pause there, the system might calculate that the cost of guessing today and being wrong is quite low. You just say, no, tomorrow, and it corrects. Easy fix, low computational overhead to undo.
Okay.
But with call Arno, the cost of calling the wrong Arnold could be high knowing someone, interrupting them, maybe making a business call to a personal contact, much harder to undo smoothly.
So in that higher stakes case, it's more likely to rely on the audio cues and wait for clarification.
Exactly. It factors in the potential consequence and resource cost of getting it wrong, using that to help decide whether to act immediately or wait for more certainty, guided by those audio characteristics.
That's really smart. It's optimizing for not just accuracy, but also for a better, less disruptive experience.
Yeah.
Okay, so let's wrap this part up. What are the main takeaways, the big advantages of this approach?
Well, the headline benefit is clearly more natural, more fluid conversations, getting away from that rigid turn-taking, which leads to fewer errors, right? Because it's waiting for your complete thought more often.
Less frustration, fewer times you have to repeat yourself.
Exactly, and that means increased efficiency. You get things done faster. Plus, as a minor point, maybe some conservation of resources by not performing incorrect actions that need to be undone.
It really does feel like a significant jump towards AI that understands us a bit more like how humans understand each other.
I think so. And circling back briefly, developing and protecting this kind of complex tech mixing ASR, NLU, acoustic analysis, machine learning It really highlights why that deep technical and legal expertise is so vital in the patenting process.
Yeah, understanding the nuances on both sides is key. You need patent attorneys who really get the technology to draft strong protection.
Absolutely. Especially in fast-moving fields like AI, having that specialist knowledge, again, like someone like yourself, Bastian, focusing on AI and software patents, makes a real difference in capturing the essence of the invention properly.
It certainly keeps things interesting. Okay, well, this has been a fantastic deep dive. We've seen how this patent aims to solve that classic voice assistant problem, the unnatural turn-based flow, by cleverly listening not just to what we say, but how we say it, using those audio cues to handle pauses more intelligently.
Yeah, it's a move towards assistants that adapt to our natural speech patterns rather than forcing us into theirs, a much more human-centered approach.
Which leads us to a final thought for you, our listeners. As AI gets better at understanding these subtle conversational cues, how is that going to change things? How will it reshape our expectations when we talk to technology?
Will we start expecting this level of understanding everywhere? Will it change how we think about human-computer interaction itself?
Something to chew on. Maybe think about your own voice assistant interactions. Have you hit these frustrations? How would this kind of tech change that experience for you?
It's definitely worth considering where else this deeper understanding of conversational nuance might pop up in AI in the future.
And that's a wrap for this episode of AI Patent Watch. If you found this helpful, please take a moment to leave a 5-star rating and subscribe so you don't miss future episodes. This podcast is curated by Bastian Best, a European patent attorney specializing in AI patents. To learn more about the exciting intersection of patents and AI, sign up for his mailing list for exclusive insights. Link in the show notes. And if you're already working on the next big AI innovation, now's the time to secure your own patent. Reach out to Bastian on LinkedIn or the podcast website to turn your ideas into assets. Thanks for listening, and stay tuned for the next episode of AI Patent Watch.